Thank you for coming. It's a little bit hot here, so for those of you who will be very active, I have this one, and trust me, it may help here. So today I'm gonna talk to you about key leaks from the cloud infrastructures. Before, oh, okay. Okay, so before we can start, let me introduce myself. My name is Paweł Rzepa, and I'm from Securing. I'm the senior security consultant. On my daily basis, I'm doing penetration tests. However, recently also I'm doing a consultancy job in cloud security. You can find some of my articles on Medium. All my programs. Today I'm going to release, I'm going to talk about two of my tools. You can find it on my GitHub account, and if you're using Twitter, here's the nickname, you can find me there. All right. Sorry guys, but it doesn't work. Okay. So, what are we going to talk today? First of all, I'm going to tell you about the key leaks, how it is possible, the key leaks in your company, and it is regardless the service provider. So no matter if you are using the AWS, no matter if you are using Azure or GCP, whatever, the problem is not in the service provider. And after all, I want to propose my solution to it and also a few countermeasures that you can implement in your company. So what is the plan? First of all, what is the difference between the passwords and keys? Key leaks from the public, not only public, from the storage containers. What about one of our employee account will be compromised? What about key leaks from the web applications and other external services? Key leaks over third parties like the GitHub, Pastebin, and whatever. Then I will try to explain you what the entropy is, the whole background of entropy, and how can we implement it in some solution. After all, I will tell you some about my tool Dumpster Diver, which you can find on GitHub, and hope it will help you in your companies. After all, there will be countermeasures and also one extras, but it will be at the end, so, so stay with me. Okay, so first of all, what is the difference between passwords and access keys? First of all, the access key ID is actually the same as login. However, it is the random string. And the secret access key is a password. However, it is even longer random string. So there is no big difference at the first glance. However, what is so special, the keys are always hard-coded. We are taught not to hard-code passwords, and actually it is not very common to find hard-coded passwords. However, regarding access keys, it is really, really common. What is more, we are forced, usually we are forced to rotate passwords, like changing the password every 90 days. However, regarding access keys, it is really, really rather situation that you are forced to rotate your keys, especially if you have couple of services which are interacting with each other, then those keys are not rotated. And another interesting thing is the multi-factor authentication. It is a very trivial example when we are talking about the normal login password and the multi-factor authentication. However, if we are talking about the programmatic access for AWS user or the Azure user, multi-factor authentication is really difficult to implement. So you have to implement a separate policy which will be enforcing you to use this to use the MFA device. I wrote a little guide about it, so if any one of you is interested in how to implement it, you can find it on Medium. Now, let's talk about the key leaks from the storage containers. So here's a very basic graph. However, sometimes giving the IAM role, giving the access control is difficult, but if you give the public access, it always works. So there are still administrators who believe that, oh, okay, well, if I give the public access, it will always work. And yeah, they are still doing it. What is more, Amazon also, they created a group, any authenticated AWS user. And literally, it means exactly how it sounds. So any authenticated AWS user. That means that if I create the free tier account, that means I'm in this group. And a lot of administrators believe that there's no point in such group. So most likely, it will referring only to my people, to my users, which I created under my root account, but it doesn't. So this group currently, it is removed from the UI console when you are configuring the IAM role. However, you can still assign it using the AWS CLI. What is more, this group existed from the 2006, so from the very beginning of the S3 service, till the mid of 2017, 11 years. So a lot of administrators use this group. Now, so if we have these public storage containers, and well, I decided to check if I can find anything interesting in this. So I defined a target like the low-hanging fruits, like any file containing a backup word. So, first of all, there wasn't available a scanner, so I created my own, which is the bucket scanner, and it verifies the privileges to the object in the S3 bucket. So, here's the manual, let's say, and you can define a list of buckets, and it will simply read the content of the bucket if it has the privileges to it. And also, you can specify a regular expression for each object it will find in the bucket. So, I created a simple list where you can find those two buckets. There are test ones, so nothing spectacular now. So yeah, you are defining the list to the list of those buckets and the regular expression to any file containing a word backup. Another interesting thing that you can do this scan as an anonymous user, or you can specify the keys. So for example, you want to check inside your company if one user has access to those objects. So in this short demo, it found that, okay, it is collectible, the file backup.zip or the backup.targz. Cool. But now we need a list, an enormous list containing a lot of buckets. How we can find them? First of all, finding a bucket in the Amazon infrastructure is actually finding a subdomain of s3amazonaws.com. You can also refer to the bucket using the AWS endpoint and then the bucket name. However, this one, I'm using both of those links. For example, there were a lot of leaks. Like, for example, if you typed the Chicago DB a couple months ago, you found a backup of the database containing almost 2 million private data of almost 2 million voters in Chicago. So the company which was responsible for the technical side of voting in US, they put their backup data in the open bucket. So if we know that we have to find the subdomain of s3aws.com, we have some options. For example, we can carry the third parties like the Google, Yahoo, VirusTotal, Bing, whoever uses Bing, and certificate transparency logs. Who's using Sublister? Anyone? Okay, so the AMAS is much better than Sublister. So you stop using Sublister because AMAS is much better. It is actually released, it's quite new tool, but it really rules. So AMAS is asking all those third parties, but also the certificate transparency logs. Bucket Stream only asks the certificate transparency logs. Basically, the certificate transparency logs is a pool containing all the HTTPS domains. So if you create a new HTTPS domain, you can find it in the certificate transparency logs, which has an open API, and you can ask. So you can ask it. So it's a great source of subdomains. What is more, you can ask the Wayback Machine. So Wayback Machine is actually the archive.org. It's the bot which is scrolling all the internet, finding the picture or file and doing a copy of it. However, if this bot finds just one photo of in your bucket, then you can just pull the name of the bucket from it and see if it contains much more than just those photos. So I did such little research, use only those methods that appear here, and I found almost 25,000 valid buckets. 21% of them, so more than 5,000, has the public read access. Of course, not all of them contain something sensitive. However, I found thousands of backup files, and they are still there. Nobody is doing anything with it. And inside of those backup files, there are a lot of scripts, config files containing passwords to services, containing private keys, SSH keys, containing whole databases. Even if the password is hashed, there is no salt used. So what about Azure? Maybe Amazon sucks and Azure is better. So first of all, there's no groups like any authenticated Azure user. That's good. And to find also to be able to list the content of the container, you have to find two variables. So the storage account name and the container name. However, the problem is still there, that still administrators believe that it is undetectable, but it is. Okay, key leaks via compromised account. If you remember this is my little research, the bucket scanner, the tool that I show you, it also has the possibility to test the upload privileges. And 6% of those 25,000 buckets allows me to write and overwrite file. So even if I don't have a privilege to delete a file, I can overwrite it with the empty file, right? Which is basically the same. So now imagine the following scenario. If all the employees trust the bucket, because this is the bucket of the company, right? So if I overwrite a trusted file, then it will go to all the employees, right? So it's a great source of distribution malware. And if it is used by the external service, then it can go to your customers. All right, so of course there are numerous ways to infect employees' computer. You are the experts here, so you know exactly how it works. However, on the compromised computer, you can find always the local config files, and is also, if you are using the AWS, there is .aws credentials, and all the keys are stored there. So enforcing multi-factor authentication is a must. It may be quite problematic. However, still, I wrote this guide how to implement such policy. Hope it is quite easy to implement. Interesting attitude to manage the privileges is the Netflix repo kit. So it uses the access advisor, and basically, if I have a lot of privileges, a lot of roles assigned to my account, then the repo kit verifies, okay, you didn't use this role for 30 days, so it is trimmed from your account. Key leaks from the web applications. This is not very well known. So this is actually example of one of my projects which I have. So there was a web application which has the simple functionality of uploading a file. However, when you intercept the traffic, you could observe that there is a JavaScript which is actually asking the external API for the keys. It verifies my cookie if I'm authenticated, and if yes, it gives me the keys and the STS token. And having it, I was directly uploading files to the bucket. However, with those keys and the STS token, I was able to read all the content of these buckets. And another topic, which is can be only visible in cloud infrastructure, key leaks via metadata. So there are some vulnerabilities like unintended proxy or the server-side request forgery, and they can become extremely dangerous in cloud. So imagine the following situation. There is a web application, and your customer says, okay, my application doesn't interact with any other services. There is no backend, there is no DMZ. So I can accept the risk of server-side request forgery. Okay, but then they move to the cloud, and using the same vulnerability, you can access the metadata. Now, how it can look like? So imagine there is a web application, and after the proxy parameter, you can type any resource like, for example, the web page, and it will be reflected via this application. So if I access the metadata of the web application, there you can find the credentials of a user which is assigned to this instance on which the application is hosted. So here are the metadata and the security credentials. In the security credentials, there is a role assigned to the instance on which the application is hosted. And inside of it, you can find the access keys, the secret access keys, and token. So now let's go through it again with little more explanation. So metadata is the data about your instance. So the private IP address, the MAC address, etc. And The same concept works in AWS and Azure. You can refer using this special address to your metadata. Now, who can tell me what is so special about this address? Sorry? Indeed, indeed. First, it's for you. Enjoy. Exactly. It is not routable address, so it works only in one network segment. That means that if you are logged into your EC2 instance, then you can refer the metadata of this instance. However, if I type the same address in my local browser, it will show me nothing. And talking about the Azure, here is not the IAM, but identity. However, still you can access it using the same address and access the shared key. Okay, how can we catch such leaks? Automated tools will usually fail, and still penetration tests are remedium. So pen testers, don't be afraid of cloud. Key leaks over third parties. So we are used to use services like Stack Overflow, right? So people type the snippet of the code to the Stack Overflow and asks, hey, Mama, this code doesn't work. Can you help me? Or on a forum, or on Pastebin, or whatever else. However, in cloud, you have to type the access keys there to be able to run this script. And unfortunately, it is a source of many key leaks. For example, here's the Pastebin, and someone just shared in a secure way keys, right? However, the Pastebin key still can be, it is analyzed all the time by bots. And this is quite interesting. So you don't have to use GitHub to see your keys there. And this is the story from the previous year from the company called All In Data. Has anyone heard about this All In Data company? Okay, not a lot. So there was, they were hiring a new engineer, okay? So the Walter, who is the CEO of this company, he decided that he will create a user for the interviewee. He gives him the access keys, and this interviewee has to solve some problem. So he has to write a solution. And then this solution will be analyzed by the engineers from All In Data, and they will decide if this guy knows the stuff or not. However, this guy, he uploaded his solution to his public GitHub, right? And he shared with the engineer from All In Data only the link to his GitHub. So of course, the engineer was senior enough to report it to Walter, said, oh, wait, our keys are on the public GitHub, so they are already leaked. Walter was very busy because it was the Friday afternoon, so he said, okay, I will do it after the weekend. Now, question to you, what happened after the weekend? Any suggestions? Sorry? Indeed. So, after just one weekend, by the way, it's for you, so come later, okay? After the weekend, so after just 2-3 days, he saw that he's supposed to pay almost $100,000. Why? Because the role which was given, this gives him the possibility to run any new instance. So the criminals, they took and started the biggest instance in every region in the world, and then started mining cryptocurrency. So now you can see how that, well, it is quite usual. And actually, during one of our projects, we also observed that on the infrastructure of our customer, there is running active cryptocurrency miner. All right, so how can we catch such leaks? Of course, we have tools like Trufflehog. Has anyone used Trufflehog? Two people. Okay. So there is also the Git secrets, which is analyzing your GitHub and GitHub repository, and it is analyzing also the logs of it. So if you type in if any commit includes the keys, then those tools will find it. So it is a good way to, before publishing any repository, it is a good way to scan it using such tools. However, I thought, wait, I found keys not only in the GitHub repositories, so I would like to see a tool which is able to find those keys in any readable file. So I decided to create my own. Now, how entropy can help us. So before this, let's do a little challenge that's showing that manual search is ineffective. So we as a human beings are working like that, that first of all, we have to define a target. Let's say it will be the empty Pepsi bottle, okay? Now, what is specific about this object? Well, the logo for sure, right? So now there is a little challenge. I remind you that there are awards to win. So find an empty Pepsi bottle on the next slide, okay? So who finds it, please raise your hand. I will give you a pointer. You will show me and I give you anything. You can choose even the NFC toolkit. All right? 3, 2, 1, let's start. Where's the Pepsi? Yeah? Where? Back, yeah. Where? Come on, it's a milk box. It's not Pepsi. It's a milk box. Where? Again, exactly. It's there. Ah, yeah. For you, you have the, yeah. Now, you know, there are those services, intelligent services that can detect any object in the images, right? Now, it will be quite challenging for all those intelligent engines. So going back to our research, now, what characteristics we can say about the access keys? So what is so special about them? Any suggestions? Perfect. High entropy. What else? Okay. Thank you. Any other suggestions? So the high entropy, we will go back to it. What else? Base 64. What else? And the length, exactly. So we found all of them. So they have fixed length. All of the keys are always the same length. What is more, the keys, the characters from the keys are always coming from the base 64 car set. And they are random, what means they have high entropy. So yeah, guys, you replied good. Who else was good? Yeah, okay. Well, okay, come to me later, okay? That's 2 of them waiting for you. Now, what is the entropy? Any suggestions? What is the entropy? Source of random information. Okay, maybe an easier, yeah? Yeah, you're pretty good. The definition is quite long, but it is pretty good. I can give you later the URL, whatever you like. But simplifying your definition, the entropy means disorder. So this shows much higher entropy than this one, right? Make sense? So, going to be more scientific, we can use the probability. So, for example, imagine the three boxes, and let's count the probability of taking any ball. So, for example, in the first, you can see that only white balls there, so the probability of finding the white ball is 1, so there is low entropy. Yeah? Here, most likely you will find the white ball, however, it is still the more biggest probability is to find the white ball. And in the third bucket is the highest entropy comparing all those three buckets. So there was a guy called Claude Shannon. Do you know this guy? Oh yeah, you should know him. He's a father of information theory. So he found the formula how to count the entropy. First of all, it takes the probability, and the n number is the number of classes. So if we go to our example, here we have two classes. So one class is finding a black ball, and finding a white ball is another one. If we have the base 64, then it will be naturally all the classes, all the characters that is possible to find in the base 64 card set. So, as I said, he's the information theory father, and he found, for example, the signal sampling theory. So thanks to this guy, we have the digital signaling currently. So every IT guy, I believe, he should know the Claude Shannon. All right, so how to count it in practice? Here's the 40-byte hash, and using this formula, this hash has 3.57 entropy. Using the string, like Chuck Norris counted to infinity 20 twice, has 3.81 entropy. Here's another string with shrug, but it contains characters out of base 64, so we shouldn't analyze it. And comparing to it, the AWS secret key has the 4.67 entropy. All right? So you can see the significant difference between the other strings. And when I was doing those experiments on many AWS secret keys, so I was rotating it and counted, and I found that they have always entropy higher than 4.3. So, finally, we are going to the tool which I want to present you, the dumpster diver. It has even the ASCII art. Main features, first of all, it's open source, so it's free, so on the MIT license, so you can do whatever you like. It uses Shannon entropy to find the private keys in any readable file. It will search any archive, so if it is a zipped without password or any other protection, it will unpack it and analyze every file inside of this archive. It searches also through the Git repositories, so if you are using the Trufflehawk, then this tool, I believe, it's like the Trufflehawk on steroids. So it will analyze every file, but also find the key leaks in the Git logs. And what is more, it supports advanced search, but regarding this, I will show you in a moment. So, quick demo of dumpster diver. So, this is Python 3. And it is pretty simple, right? So you are specifying the local path. So let's say you are downloading the content of all the bucket to your local disk. And then you are specifying, using the p parameter, you are specifying the path to this. Yeah, so let's check out it in practice. Here you can see, you can see some test folder, and inside of it, I hide bucket scanner zip and the mail file. Okay, so such two files, one file and one archive, and in less than second, it found the entropy, the high entropy. What is so special about this tool? You can specify the length, and in Trufflehawk, it generated a lot of false positives. However, in the dumpster diver, you can specify the length. So, for example, you are searching only 40-byte strings, so only the AWS keys. But if you are searching for Azure keys, you are specifying the length of Azure keys. So it can be customized. Okay? Now, so here, yeah, it shows that it is in the extracted file. So it created another folder where all the extracted files from the archive are put. First of all, let's see in the mail file. So it found in the mail file. We are going, and yes, there is so the same F2 the string starting from F2. It found this string, right? Another one is in this zip archive there was a Git repository. I know it is not very readable. However, the idea is only to point it that you can find the access keys in the Git repository. So having such information, you can manually simply go to the Git folder. So let's unzip the archive. Then you are finding a bucket scanner folder, and in the bucket scanner, there is the .git, okay, folder. So going there and using the git log -p, you can see the differences in the commit. So in the commit, which is tagged with message, oops, forgot to remove keys, you can find that those keys really exist there. Okay, so I mentioned the dumpster diver also has the ability to do an advanced search. So what is the advanced search? First of all, it can do a simple grab. So if you are analyzing a lot of files, then you can, for example, just want to simply grab something, right? You can create a simple rules like, for example, the mail leaks. So if it finds in the file types like DB or SQL more than 10 mails, then it will the rule will be triggered and you will be notified. And of course, it supports the wildcards, and you can specify a lot of them. So if any of it will be triggered, then you will be notified. Okay, so use case scenario, which I see, scanning big volumes of data manually is quite ineffective. So dumpster diver will quickly do it for you because it supports multiprocessing. Another way how you can use it is to create a quasi data leak prevention system. So imagine the following situation: you have a bucket, all the employees are putting the files to this bucket, and if a new file is in the bucket, then the AWS Lambda or Azure Functions is triggered, the file is scanned, and if it contains some grabbing words which you don't want or the high entropy, then it will be blocked and you will be notified. If not, then it will be placed in the right bucket. Now, this tool is quite fresh, so any feedback about it, any suggestions what this tool can do are more than welcome. Yeah, this tool is on an MIT license, so if you want, just go do whatever you like. Countermeasures. So first of all, set proper access to your resources. It is easier to say than to do. However, if you have the large and complex architecture, however, you can use like the repo kit from the Netflix to help you. Encrypt files at rest. It seems to be obvious, but still too little people are doing it. Allow access only from VPN seems to be trivial. Enforce using multi-factor authentication. Again, if you have the problems with setting it up in the AWS infrastructure, read my guide. Create a process of verifying stored data. So every file that you are going to publish, to store, scan it. Okay? And above all, test your environment. If you want to practice your skills, there was a challenge before the confidence called KRK Analytica. Who was playing it? Okay, just few of them, a few of you. Okay, so if you, however, I got quite positive feedback about this challenge, so we decided to leave it, the infrastructure of it, and you are very welcome to play it. So here's the description of the challenge. Go find legally keys. Okay? So that's all from my side. Do you guys have any questions? Yeah.
I just wanted to ask about the first tool you were showing, this
Bucket scanner. Yeah.
So do you think it would be easy to adapt this tool to like our own S3 implementations, not the AWS ones, but we have internally S3 used in the company?
For sure, yeah. Why? Because actually it is just exchanging the method that is responsible for reading the object. So if you change this to the methods reading like the, I don't know, the Dropbox, then it will check it.
And it's also open source.
Of course, okay. On MIT, all the tools I'm publishing, I'm doing always on MIT. I still believe that we as a community should give something to the community. I'm using a lot of open source tools, so it would be awesome if anyone can use mine.
Okay, so the second question is also connected a bit to the community thing, because I've seen on your, I think, second slide that the access keys differ from the passwords because they are used to be stored in plain text in different
Indeed.
files. So perhaps we should try to encourage everyone not to do this. So for example, we are using Vault to protect those keys.
Yeah.
I guess there are several different methods that could be used. But I guess we should avoid slides like this and encourage people not to do this.
Yes, thanks. Definitely. Thank you very much. And for 2 questions, you have a special part. Yeah, thank you. Any other questions? Yeah.
Right now, putting false keys seems to be effective tactic to make noise, to trigger false positive on all files. If I put false keys, high entropy strings on all files,
Indeed.
it would generate a lot of false positives. Right now it would work, right?
Yes, yes. However, well, again, for example, when you are testing the truffle hog, it was scanning, it was giving you a lot of false positives because it was, for example, seeing the high entropy in the base64 files. So if you put in your code the image which is in base64, then Trufflehog is reporting it as a false positive. So here, yeah, I decided to just limit those false positives, but actually you cannot, you cannot be sure that if it reports, then there will be no false positives. If you have the better idea, the better attitude to even limit the false positives more, please tell me. Any other questions? Okay, guys, so thank you very much and enjoy the show.